Am I sharing the right screen?
Yes.
Okay. So good morning, everyone. My name is Luana. I work for Dr. Romulo Lolato, and I'm taking care of the winter wheat crops, for the rain. I'm going to try to be brief here, so I'm not going to give a lot of background because we're going to talk about the rain project. So basically, in the first year, we have data from Ashland Bottoms and Hutchinson, partial data from Hutchinson, actually, because we didn't go ahead with the nutrients on the plants. And for the second year, of course, we have for Ashland. The variables that we are measuring, as Romulo covered a little bit yesterday, we are doing sand count on wheat, biomass in 5 growth stages. And from the biomass, we are also taking the partitioning, and we are also doing canopy cover and yield components. So going through the first year, for both locations, of course, in the first year, we only had wheat grain, and basically the only effect that we had at the first year was nitrogen. For both locations, wheat was winter crops were drilled after soybean and the rain-fed no-tillage system. Both locations also, we had the Zenda variety at 90 pounds per acre at 70.5 inches of row spacing. Oh yeah. So basically, I'm going to just show the results for wheat grain. So we are not covering here the treatments 2, 14, 15. And also we are not covering the green in because, of course, it was the first year, so we didn't have the effects of the legumes at this point. So basically, for the first year, Ashland and Hutchinson, as we know, they have different characteristics, environment conditions and soils. So basically, we consider Ashland for this first year as a high yielding environment and Hutchinson as a low yielding environment. Sorry. So when I talk about high yielding environment, I'm talking about Ashland, and low yielding environment, I'm talking about Hutchinson. So basically, this is the descriptions for the treatments for the nitrogen effects that we had. The main difference between the treatments is that the progressive, we split the same amount of nitrogen that we apply as a normal nitrogen, but we split in 2 different growth stages, and we also applied with some nitrogen, uric acid and nitrification inhibitors. Oh, and also the placement method is different. So for the normal, we just broadcast in the placement for the progressive string bar. And then going to the results for the first year, the top table, you see the results for Ashland Bottoms, and the table in the bottom, you see the results for Hutchinson. We don't have a whole lot of difference for the variables that we measure it for Hutchinson, but for Ashland Bottoms, we actually have some interesting results here. We see difference in test weight, protein content, and also yield. So this is something that we don't find very often in literature, which is protein and yield increasing at the same time. And basically, we saw better protein and yield increase for the progressive treatments here. So this is the plant nitrogen uptake during the season. So here in the left top table graph, you can see for the whole plant. So basically for all the stages that we are collecting the biomass. In the bottom, we see in the light purple, it was the N application a little bit before the Sawdox 32 for the normal, and the first application for the progressive. And then in the top, you can see when it was the timing for the second progressive any application. So basically, we can see here for the whole plant that progressive actually absorbed more nitrogen over the growing season. And we believe that's one of the reasons that actually provide more nitrogen for producing protein in the grain and the yield. And then we can also see in the stover, again, they kind of follow the same trend, but for progressive treatment, the nitrogen absorption was higher. And now in uptake in the head and in the grain, we can see that, again, progressive and normal, they both follow the same trend, but always progressive treatment has a little bit higher absorption than the normal one. And even it's interesting to see that for the grain, by the end of the harvest index, which is the Zadox 92, we can see they kind of like balance out, but because we had more nitrogen being absorbed the entire time, that's actually what ended up translating more protein and yield for our results. And sorry, just this results is for ashland bottoms, like I said, because we didn't go ahead for Hutchinson. We don't have results for plant nitrogen in Hutchinson. So basically, the conclusions for the first year, integrated N management may enhance nitrogen use efficiency without we needing to extra fertilizer. It was the same amount fertilizer for both treatments. It's just different methods of applications and timing, and the use or the lack of nitrogen urease inhibitors. But we only see this difference in high yielding environments. So probably the reason why we don't see this in Hutchinson is because we didn't have enough water to actually, so this is the progressive treatment. I see more like a fine adjustment by the end of the story. If you have enough water, if you are doing everything right, then you can start to thinking about progressive treatment, at least as of the first year, how things were looking like. And we believe that also because it absorbed more nitrogen and they produce also the same amount of biomass, which is really important to take note on it when we're analyzing nitrogen use efficiency. So we assume that the wheat had better nitrogen allocation within the plant, aside to the also higher nitrogen uptake during the growing season. So basically, I'm going to go ahead and talk about the second year. We did have a little bit less precipitation in ashland than the first year, but still it's enough for winter wheat. And basically, we have the list here of the 17 treatments. Again, I'm not talking about treatments 12, 13, and treatment 2, because basically they're haze. So if you want more results on this, you can check on Rudolph's poster. And also treatments 8 and 9, they were winter fallow, so we are not covering here. Those treatments that have the same color, the colorful colors, so the blue colors, they basically the same as of this year, so they did not differ in anything. The orange as well and the green as well. I do not have the column here for planting date, but we also have different planting dates for these treatments for winter wheat. But they're also the same planting dates for the treatments that we have the same color. So basically we end up with 9 treatments, and that's how we kind of analyzed. The factors that we have here now, it's planting date, nitrogen, and crop sequence. We also applied the same starter fertilizer rate as the first year, the same wheat variety for the first year, row spacing. However, this year for the early and the late planting date, we increased the seeding rate, and the optimum, we kept the same seeding rate that we had in the first year. And then going ahead to the yield results, we can see that nitrogen didn't play a whole lot of role here for wheat, but for the treatments with higher yields, we can definitely see that the only thing that they have in common is the optimal planting date, while the treatments that had the lowest, they were the early planting date. But it's also important to highlight here that for the early planting date, though, this is a dual purpose wheat after green nitrogen. So we don't have any early planting date for the other treatments. So the only treatments that are representing for the early planting dates are the green N. And so I don't know how much that actually translates to the reality of, hey, early planting date is the worst for wheat in this case, for example. I wouldn't think it like that. So if we take a look only by planting date and yield, we can see like how high up was the optimal yield for winter wheat compared to the early and late. But like I said, it's hard to actually define this early planting date as really representative. So basically here is the biomass data. Again, the shoot biomass, we still don't have, we are still processing the data for the nitrogen uptake, but we only have the biomass data for this. Again, the same thing for biomass. We have the 90 treatments, but if you look at the dashes and the optimum planting date, they are always higher up compared to the late and early. Again, early, of course, is always down compared to the late as well, because like I said, still it's not as representative as it should be. Canopy cover also follows the same trend as biomass, which was something that we were actually expecting. And this is a very nice picture that we took and we saw in the field. So in the left side, we have the from the overall table that we have from the original table of the experiment is a treatment 7, and in the right we have the treatment 4. Basically, the difference between them is that in the left one we have the latent planting date, and in the right side we have the optimum planting date. Even though we increase the seeding rate, still optimum planting date with lower rate translated in better canopy cover, biomass, and also yield. Again, left side was also progressive N, and the right side was normal N, and it's still the right side, because of the optimum planting date, was still overcoming the left treatment. And the left one was after soybean, and the right one was a continuous winter wheat as of right now. But I believe it's going to change next year, because the right picture is not the baseline. It was just continuous wheat as of this year. Sorry. And then here we have some data for the hay part. This consists of the fixed 6, which is the Zadox 32 growth stage. I'm including the hay treatments there, so that's why now we see 10, 11, 12 treatments. We do not have the treatment 8 and 9 that I showed from the combined treatments that I did, because the treatments 8 and 9 is dual purpose. It was the green end, so at the time that we collect fixed 6, we were still mowing that treatment, so there was no biomass there. And basically, we can see that for the hay treatment at fixed 6, we can see that they're like considering higher biomass compared to the other treatments, which is actually good, because that's what we're expecting for the hay treatments, and they're also planted earlier as well. So yeah, with that, I try to be brief.